Hello. Our goal is to find the antiderivative of the function 6x squared plus 8x times sine of 4x. Let us integrate the function 6x squared plus 8x times sine of 4x. See that, the function we have to integrate is a product of a nonlinear function and a polynomial function. The method appropriate in this case is the method of integration by parts. Let us briefly review the method of integration by parts. We know that the integral of u dv is equal to u times v, minus the integral of v du. Consequently, we set u equal to 6x squared plus 8x, so du equals 12x plus 8 dx. And dv equals to sine of 4x dx, and v equals to minus 1 over 4 times cosine of 4x. Ultimately, the integral of 6x squared plus 8x times sine of 4x dx is equal to minus 6x squared minus 8x over 4 times cosine of 4x, plus the integral of 12x, plus 8 over 4 times cosine of 4x dx. Consequently, we still have to integrate 12x, plus 8 over 4 times cosine of 4x, using integration by parts. Let us integrate the function 12x, plus 8 over 4 times cosine of 4x. We know that, the function we have to integrate is a product of a nonlinear function and a polynomial function. The method appropriate in this case is the method of integration by parts. Given that the function to integrate 12x, plus 8 over 4 times cosine of 4x is still the product of a nonlinear function with a polynomial function, we still have to use the method of integration by parts. The main aim of these repeated utilization of the method of integration by parts is to reduce the degree of the polynomial function, minus 12x, minus 8 over 4. In fact, the integral of u dv is equal to u times v, minus the integral of v du. In sum, we set u equal to minus 12x, minus 8 over 4, so du equals minus 3 dx. And dv equals to minus 1 times cosine of 4x dx, and v equals to minus 1 over 4 times sine of 4x. In sum, the integral of 12x, plus 8 over 4 times cosine of 4x dx is equal to 12x, plus 8 over 16 times sine of 4x, plus 3 over 16 times cosine of 4x, plus a constant c. Now we have to aggregate the results of these repeated applications of the integration by parts to get the final value of the antiderivative of 6x squared, plus 8x times sine of 4x. The first integration by parts gave the following result. So, the integral of 6x squared, plus 8x times sine of 4x dx is equal to minus 6x squared, minus 8x over 4 times cosine of 4x, plus the integral of minus 3 over 4 times sine of 4x dx. From the second integration by parts we obtain the following result. So, the integral of minus 3 over 4 times sine of 4x dx is equal to 12x, plus 8 over 16 times sine of 4x, plus 3 over 16 times cosine of 4x plus a constant of integration c. Finally, combining the last two results, we see that, the integral of 6x squared, plus 8x times sine of 4x dx is equal to minus 6x squared, minus 8x over 4 times cosine of 4x, plus 12x, plus 8 over 16 times sine of 4x, plus 3 over 16 times cosine of 4x plus a constant of integration c. Thank you for viewing this video. Please subscribe to our channel. We have an extensive collection of calculus videos covering limits, derivatives, series, integration, and many other calculus-related topics such as probability and differential equations.